Okay, so on this one, what we're going to look at is surface area of pyramids and cones. Okay, so it's going to have a lot of similar characteristics to prisms and cylinders, but a little bit different. Okay, so again, looking at our formula sheet, we are looking at surface area of pyramids and cones. Oh, there you are. Okay. So a little bit different terminology. I included a picture down here to help you out, right? So if we look at that formula, capital B is the same as before. It's the area of the base. Capital P is the perimeter of the base. This time, though, with pyramids and cones, we need the slant length, which is the height of the lateral triangle. We know on a pyramid, right, we can see it in the picture there. Instead of rectangles as the lateral sides, we now have triangles. So that slant height is like the height of that triangle on the outside. Okay, don't confuse that with the height of the pyramid. Height of the pyramid is like from the center of the base to the tip. Slant height is that distance of the height of the triangle that's on the lateral side. We need that to be able to figure out the area of that triangle. Okay, slant height on a cone is just that slanted side of the cone, where the height of the cone is like from the center to the center of the circle. Okay, so slant height is that height on the outside, where the height of a pyramid or a cone goes through the middle. So we just have to be a little bit careful with that. Okay, so our formula for a pyramid is the area of the base plus 1/2 the perimeter of the base times the slant height. Okay, so let's look at some examples. Okay, so again, our formula is area of the base. We only have one base with a pyramid. 1/2 because we're dealing with triangles. Okay, the perimeter is going to add all those bases of those triangles together. And then the slant length, okay, is like the height of that triangle. Okay, so again, just individually figure those parts out. Area of the base, well, in this one, we have a rectangle, so it's just 6 times 3, which is 18. Okay, the perimeter of the base, well, it's a rectangle, so we have 6, 3, 6, 3. So 6 plus 3, and we can double that. There's 2 lengths and 2 widths to get 18. Okay. And then the slant length, we see right here is the height of the lateral triangle is 5. Right, so again, once you identify those pieces, it's just a matter of plugging it into the formula. So the area of the base is 18 plus 1/2. Again, we do the half because we're dealing with a triangle, times the perimeter of 18 times the slant length of 5. Okay. Right, half of 18 is 9, 9 times 5 is 45. And that will get you 63 centimeters squared. Again, we're dealing with area, so units squared. Oops. There we go. I'll get that on the screen for you. Okay. So again, identify the area of the base, the perimeter of the base, the slant length. Okay. Plug those into the formula. All right. Triangular pyramid. Okay. Again, the triangle is the base. So we need to find the area of that base. So we look for that right angle, right? 3 and 4 are base and our height. So 1/2 times 3 times 4, which is 6. So 6 is the area of our base. Perimeter, just add up the sides, 3, 4, and 5. Add those together to get the perimeter. That's 12. Okay. And our slant height, our slant length is the height of that lateral triangle. In this case, it's 4. Okay. So then we would do the area of the base is 6 plus 1/2 times the perimeter of the base, which is 12, times the slant height, which is 4. Okay. Half of 12 is 6. 6 and 4 is 24. 6 times plus 24 gets you 30 centimeters squared. Oops, there we go. So again, area of the base, 1/2 times the perimeter of the base times the slant length. Simplify that down to 30 centimeters squared. Okay, we've got the one base, we've got our 3 triangles. Okay, that'll get us our lateral area. All right, for a cone, again, we're just going to take the area of the base, which is now a circle, so that's pi r squared. Okay. And then pi times radius times slant length. We end up doing half of the diameter. Diameter times pi is the circumference, but we need to do half of that. So that's why we use the radius there. Okay. So these are pretty simple. Just plug in your radius. Your radius is 4. Okay. Pi times 4, and your slant length is 6. So pi, again, use your calculator here, times 4 squared plus pi times 4 times 6, or 24 there. And again, we round it to about nearest whole number, 126 centimeters squared. Okay. So again, just follow those formulas, identify what those things are. Now, occasionally, we may have to find that slant height or find a missing piece. Okay, example, like on this one, right? If I don't give you the 5 and we need the 5, right, we're going to use that Pythagorean theorem, right? 3, 4, right? Don't know that, but we can use the Pythagorean theorem to figure that out. Or if I know on a cone, for example, let's say I knew this was, let's say 5, and instead of the slant length, I give you the height, and I make that, let's say 8, right? We need to find the slant length. Well, there's our right triangle. So we can use the Pythagorean theorem to actually help us find the slant length in certain cases, right? We can go 5 squared plus 8 squared equals c squared. Go through our Pythagorean theorem steps, right? And we can figure out it's the square root of 89. And then we can use that in our calculations. So I think there's 1 or 2 on the homework where you have to do that, where I give you the height and you have to use your Pythagorean theorem to find the missing thing. So don't freak out on that. We know how to do that. It's just a matter of identifying that right triangle and doing that. Okay. So again, use your formula sheet. You've got your surface area of pyramids and cones. Okay. Pyramids, cones, those are explained again. Again, these things are going to have the same meaning as prisms and cylinders. Okay. And then if you get a little confused again with the slant height, we're looking at the side of the triangle, the lateral triangle, the height of that. Okay. The height of the prism again, or I'm sorry, the pyramid is that point down to the center. So we're not using that for this. Okay.